Hello everyone, welcome to this new session. So this class we try to discuss something about the extension of Cauchy Goursat theorem. So what was Cauchy Goursat theorem is that if fz is a function which is analytic on and within a simple closed curve C, then the integration will be 0. For example, if we take a circle, so this is C, then if I take a function say fz z square, then integration z square dz on this circle will be 0. So this will help us for doing such long calculation. So this one you can also check also, if you can take z in a polar form, you can get dz and it should be 0 to 2 pi. So you can check this also, okay. So now this was valid only for the simple closed curve. What is the meaning of closed curve? That means the starting point and the end point will be same, and simple means there should not be any self intersection, like this one is not simple but this one is simple, this one is simple. So simple means there should not be any self intersection, okay. Now what is the extension? So carefully you look into the diagram. Suppose there is a curve C. Carefully see, we have given some arrow in the curve. It means it is anti-clockwise or positive sense. So something is there which is called anti-clockwise or positive sense. That means when you are going or when you are traveling along the curve, the region should be in your left. So you reach here, again when you are coming, the region is in your left. So this is anti-clockwise. And say within this there are few more regions. Say but this one is in clockwise direction. So we have given a curve C which is anti-clockwise direction, and we have given within that curve we have given few curves, say CK, which are in clockwise direction, and K is 1 to n. And fz is a function where on this part. Fz is a function on this part, okay, which is analytic, and on this shaded region, that is outside this small holes and inside the bigger one. So that is in the remaining portion. Then the extension is saying that integration C fz dz plus summation integration ck fz dz k equals to 1 to n equals to 0. So what does that mean? The meaning is that you take the integration on the bigger curve, then you take the integration on each one of the smaller curve, you add them, the addition will be 0. But what is the condition? C should be anti-clockwise and this individual curve C1, C2, Cn, this should be clockwise direction. That means the direction of C and direction of CK will be opposite. So what we have got basically this one if I extend, so this is basically C fz dz plus summation, that is C1 fz dz plus C2 fz dz plus plus Cn fz dz equals to 0. So this portion is the summation portion. Understand? So this is the very important thing, just only you have to understand the direction. Now let me give another idea. Suppose you think, suppose integration 0 to 1 x dx. What will be the value? The value will be x square by 2, then 0 and 1, so it will be half. Now if you change the limit, or if you interchange the limit, so 1 to 0 x dx, so it should be x square by 2, 1, 0, so it should be minus half. That means if you change the limit, then it should be opposite sign. So basically what we are saying, if this is a 0 point, if this is 1 point, if you go from 0 to 1, then your limit will be half. But if you reverse, then the limit will be minus half. That is, if you go in one direction, what will be the limit, or what will be the result? If you came in the opposite direction, the result will be exactly opposite. So what is the meaning of this? The meaning of this is that C fz dz is equals to, say, if I take C in the opposite direction minus, so we are taking the same thing but in the opposite direction, so it will be C fz dz, this one with a negative sign. So if you take the curve in a opposite direction, so it will be in the negative of the original integration. Now let us apply the previous formula. Say there are two curves, so there are two circles. One circle is this one, say this is of radius 2, and say another circle is this one, this is of radius 1. This one is C1, this one is C2. Say, now both are in anti-clockwise direction. So we have taken two circles, C1 anti-clockwise, C2 also anti-clockwise. Then how can we say, or how we can apply the theorem? So the result is saying, if this is the situation that both are going in the same direction, then integration over C1 fz dz will be same as integration over C2 fz dz. So let us just prove this one. So now suppose for the time being, if I change the notation, or if I change the direction of C2, then what will be there? So let us write minus C2, or let us take the opposite direction of C2. So integration over C2 fz dz can be written minus C2 fz dz. So from the previous theorem, what we can say, so if the direction was opposite, then C1 fz dz plus minus C2 fz dz equals to 0 if the direction was opposite, because one is in this direction, another is also in the same direction, but if it was opposite, then this will be the situation. Now what is this? C1 fz dz minus C2 means it will be minus of normal C2 fz dz equals to 0. So C1 fz dz equals to C2 fz dz. Understand? So this one is not very easy. What I am saying, both the equation or both the circle is given in the same direction. Then we have to show that integration over the bigger circle is same as integration over the smaller circle. So what we have done, initially we apply the previous formula by taking the smaller circle in the opposite direction. Now the opposite direction means it will be the original direction with a negative sign. So that will give us the thing. So this is very important. That means if you integrate something with respect to a big circle, okay, if you integrate some analytic function fz equals to z square with respect to a circle mod z equals to 9, then what will be the value? If you do mod z equals to 2, the value will be same, provided the smaller one will be inside the bigger one. They will be inside the bigger one. Okay. Another example, not example, another fact. Suppose again I am taking a circle, say C1, and within the circle I am taking a square. C2. The same result, so we have to show integration C1 fz dz is same as C2 fz dz. So what we will be doing? We take, so first of all we know that if I take minus C2 fz dz, that means if I take C2, the inside portion, if I take in opposite direction, then it is nothing but minus of C2 fz dz. This we know, because if I change the direction, the value will be changing. So from the previous theorem we can write integration C1 fz dz plus integration minus C2 fz dz equals to. Now you can ask, sir, why you have taken the different direction for the inside portion? Because the theorem tells that the outer one will be anti-clockwise direction, the lower one should be clockwise direction. Now here we have considered the lower one clockwise direction, because C2 was anti-clockwise, so minus C2 will be clockwise. So now we can apply the theorem. So this equals to C1 fz dz. Now minus C2 means I can write minus of C2 fz dz equals to 0. So this will give you the result. So that means that's all for this session. So what is the main thing is that always you have to understand the extension of the theorem, Cauchy Goursat theorem. So Cauchy Goursat theorem is not only valid for a simple curve, it is also valid for this type of situation. So in a competitive examination or in some special examination, if you have got this kind of problem where one circle is inscribed within another circle, or two closed curve, it may not be circle, it may not be anything. Say this is one curve, this is one curve. So this is C1, this is C2. Then the integration, whatever function you do the integration with respect to C2, what will be the value with respect to C1? The value will be exactly same. So that is the main thing of the class. So please visit this one, and for more information you see the previous videos also, so that you can get a proper understanding. Thank you.